So there was a total of 50 points. Let's see, what did I say? So I said that the working code was 30%, new testing 20%, common 10%, quality code 30%, which meant that the quality code, there was 15 points. So some of you, when you have to score, once they took off, it'll be more than I gave you, because if you lost 20 points on the quality code, I want to say I can only take out 15, right? So you got lucky. So let's go through some of the issues. Let's see. Knowledge first element is circular Q, as element of circular Q class. Yep. That it is, right? That's pretty clear. I don't think we need to tell anyone that that's a field in that class. Nor do I think we need to tell someone that's a constructor. Right? Call these duh comments because, like, you're just repeating what's obvious about the code. So why did you waste your time? Right? You know, if I got something called the first node and last node, okay, that's pretty clear. But what may not be clear is, oh, it's circular, right? It's doubly linked, so you may want to explain that. But just repeating what the type is in the class name, it really doesn't help us to understand what's going on. So I took points off. Depending on how many of these comments you had, I took more points off. And for those of you who didn't grow up in this country, there was this famous TV show, The Simpsons, or duh is like a common expression.
It's dough.
Dough. Dough? Okay. I only watched it once or twice when I was on TV, so like. Yes, but I'm going to link Q class, and I have an insert method. I pretty much can assume that it's going to insert that element into the Q, right? Here's another example of now some people write their add method or insert method. It listed all the parameters, right, that would go into a process. Once you do that, that Q only works in this assignment, right? When else are you going to have a Q that needs those elements in objects, right? It's not going to happen. You know, so we talked about object-oriented programming being good for code reuse and easy to expand, etc. But this is a hard-coded Q class for one assignment, and never can't be used again. Then there was this, sorting thing, right? How do we deal with that? So some people, they passed in a string, and then someplace they've got this case statement or a switch statement or a bunch of ifs. So the problem with this is that to use this method, I have to know what those strings are. And those strings are only inside the method. So now I need to go inside the method and see what the strings are before I can use this function, right? And we talked about the point of object-oriented programming is information hiding, so I don't have to know what's going on inside, right? Just do your work. But here is an example where I have to know what's going on inside before I can use a function. Right? There's no information on it. It's like, oh, we have to dig inside to see what those strings are. Uppercase, lowercase, spaces, no spaces, right? If you get it wrong, you're in trouble. Right? We talked about information hiding. We want to hide the decisions. How am I going to select the right thing? Well, we can do it different ways, so can we hide it? Well, one way is, right, I can make some sort of static final things in Java, and then internally I use those, and externally I can use them, so now we don't have to worry about, right, what the exact strings are. They don't even have to be strings, they could be numbers, it could be anything, right? So it's an improvement. It's still not great. Why? Because now there's a fixed number of ways I can sort, right? That's it. What if I want to sort by owner, and then inside of owner I want to sort by something else, right? If we don't have that here, then we can't do it. So again, it's not very flexible. Right? If you want to sort by a different way, then we can't until we modify that function. And so in Java, we've got this comparator thing, right? So we pass in this comparator, and we use that to pass on to our sort routine. Now, the caller can decide how they want to compare things to sort. Right? So this is far more flexible. It gives us it's a callability. Okay, I want to sort first by owner, and inside owner I want to sort by time. Whatever we want. Right? So you see this is more flexible, right, than hard coding the string. But we're in Java, right? And this get process info by sort by what? No. Java has this method that almost all the question processes have called toArray. Right? And what does that do? It returns an array of the objects that were inside that collection. And so then we can just become more standardized. So once we do this, then we can just use a standard Java method toArray, return an array of objects called sorting. I mean, what's a Q class supposed to do? What's its responsibility? It's first in, first out, right? That's what a Q does. It holds the elements and keeps them in the right order. That's it. So why do you want to have all the sorting going on inside the Q class? That's not what a Q class should do. Right? What Java collections do is they return an array of objects inside the collection, and now the caller can do what they want with that collection. And oh, by the way, right, when they get the requirements, the assignment, it didn't say you had to sort it. It is said that the program that uses your code needs to be able to sort it, right? So now it becomes a negotiation between the caller and the Q class. How should we allocate the responsibility to get this done? If I return an array of process objects, right, the caller can now do what they want with that list. So we can basically handle this requirement by just returning a list of elements. Caller can now sort them however they want. Right? Whenever we're building a program, right, and have more than one class, there's always a question of whose responsibility is it to do what. Right? And we have to negotiate that. Right? We talked about a couple of heuristics. One is the class should capture only one key abstraction. And what's the abstraction for a queue? It's first in, first out. If we need other requirements, then who should do that? What class should do that? What object should do that? Do we need the queue class to do that? No, we can create more classes, right? And keep that one in mind. And remember the Dilbert cartoon, right? Where Wally is always trying to avoid responsibility. Right? And this is my paper, everything I do about my program I learned from Dilbert. Number one is never do work that someone else to do for you, right? Does the Q class need to sort things? No, I can just say, here's an array of all the objects I got. You go at it, right? And it really is, encapsulate is, what should we encapsulate here and what should we encapsulate there, right? And it's like avoid responsibility, right? So the Q class is okay. This is not my job. My job is first in, first out, right? And going when I need to, and all that. So there are a couple of people like, okay, you've got this enqueue thing, you put a process in, and you store it there, and then when you dequeue, you return a note. It's like, well, first of all, the job of a container is the whole thing to give it back to you, right? Now you put an apple in, and you get an apple in a box. It's like, where'd the box come from? Plus, once you give me the node, now there's two problems. One is, I can now traverse the entire queue and I can mess it up if I want to, right? I can play with it. But, look, I have a queue, I want the thing out that I need to do something with, right? And now you have to force me to understand what this node does, how to get the thing out of the node. One of the things about information hiding is there's details I don't need to know. I can forget about them, right? I don't want to know those details. Just give me the apple back, right? Give me whatever's in there back. But you force me to understand, what was that you're using a node class, and because of node class we got to get things out. So it's a little bit dangerous if people then come up with a node class and change your links. And secondly, you're making them do extra work that just gets in the way. It doesn't help them in any way whatsoever, right? So in this information, you're not hiding information. Another way this happens is we just make them public, right? Now, the Python people, right, basically everything is public in Python. But you still want to let the reader know what things they can use and they can't use, right? And so in Python, there's a convention that when you have methods that you want to consider private, that is, shouldn't be called by other people, you start them with an underscore, right? You do the same thing with your fields, right? Just let the reader know, okay, you don't want to muck with this. I mean, it's complicated. I fixed it for you. It works. Don't worry about it. Just use the other stuff because that's what you want, right? First of all, the comment is just repeating what the code does, right? And then there's this, who are you talking to, right? I mean, my program is going to use that method. It won't see that message, right? There's no way for my program to capture that. That doesn't let out that print line. Right? And that goes to stand up. And if I'm going to use this in a program, there's no way to see that.
So that should be an exception.
If there's the question what the policy should be, right? Should the policy be return nil or you throw an exception? But turning it out, the calling program has no way to catch that, right? It only works if you're certain that someone there is in the terminal watching what's happening, right? And even then, when does that happen? I put this in production code, there's no, I mean, under what circumstances is there someone looking for the system let out? Back end? No. Mobile? No. Right? Web? Sometimes some people will go to the JavaScript console and see what's going on, but usually those are developers, right? Almost all the time, right, there's no one looking to see that message. So yeah, either you make a policy, what should happen? Right? And how do we decide what the policy should be? If we're in Java, what I would do is I would go to their custom classes and see what they do. Why? Because if they have a policy, then that's what the Java programmers are used to, so let me fit in and not confuse them by doing a different policy. All right, so go to your language collection class and say, what do they do when you ask for something in the collection exception? Do they return null, do they return nil, do they return exception, right? Otherwise, everyone has to remember, oh, this is what Java does, and this is what Bill over here does, right? And you have to remember which code came from where, and it's like, writing software is complicated enough. We don't need to make it harder on everybody, right? By having, you want standards, policy we use, and then everyone does it so we know what's going on. Yeah, who are you talking to, right? I mean, there's nobody listening. And then that comment, we can just have an is empty method, right? And now it becomes clear. If it's empty, it returns nil. That's what the comment says, right? If it's empty, it returns nil, right? So I was like, oh, it is empty, it returns nil. Done, right? So you want to ask yourself, when you're writing comments to explain your code, then you rewrite the code to make it clear so you don't need the comment. That doesn't mean comments aren't needed, it's just that in this case, it's like we can make it so that the code is clear so we don't need the comment. And then Java has a queue interface and it defines certain methods. Now, all the data structure books use NQ and DQ when they talk about queues, right? But in Java, they've got a queue interface and they've got a queue class, and they don't use NQ and DQ. Right? There's no way, you don't see that in a Java collection character. You see add and remove. Right? So what do we use when we program in Java, when you implement a queue class, right? If we use those names, that's what other programmers are going to expect, right? If I don't use those names, then I have to remember, oh, Bill wrote this one, and Joe wrote this one, and this came from Java class, right? Plus, can I interchange them? No, because you're using NQ and DQ, and all the Java classes is add and remove. There's no way I can interchange them, right? I don't get that flexibility. And if we want to be able to interchange them, it's not enough, right, to use the same names in Java. In Python it is, right? In Python that's all you need, but in Java there needs to be a common parent that we can program to an interface to, right? So yeah, we don't use is queue empty. Well, first of all, it's in the queue class, and so we know the queue is empty because we're sending a message to the queue object. So I don't need the queue part. And then Java, in all the collection classes, they don't say get size. They're inconsistent this way, right? Early on, everything was get this and get that, and then they realized, well, what? I mean, at the property on size and all the collection classes, it's just size. So you didn't want to do, right? Right now, once I do this, now it fits in. I can use this queue class or their queue class depending upon what the requirements are. I've got something that works not just in this assignment, it can work other places. Code reuse, right? And part of the problem is, as programmers, we sort of wear two hats. One is, I got a problem to solve, right? So you look at an assignment, and you're like, okay, the assignment is this, and there's something about printing, there's something about sorting, and queues, and I do this, and this, and this, and this, and this. But the other one, we're just building classes that we're going to use in a program. It's a slightly different perspective, right? When you're just writing code to accomplish a task, you're now thinking about the bigger picture. It's like, why not sort in a queue class, right? But as soon as you do that, that code becomes basically a one-time only, right? There's no, you're not going to be able to reuse it. You step back and say, wait, I'm building a collection class. So what should it do? Oh, it's a queue, so it's first in, first out. You know, keep track of the capacity, blah, blah, blah. Capacity policy of expanding, double size, all that sort of stuff, right? And now when I'm done, now I can work on my problem, right? Oh, I have to sort. How am I going to do that? Oh, I know. I'm going to give me all the elements. Now I've got an array. Now I can sort that however I want. The node class, right? You know, so we need the value and store it. You know, that's actually all the thing. And there's a next and previous, right? And then there's a set value, get next, set value, set previous, and maybe a toString. Remember in the first week, it had various heuristics, and this is one of them. We also talked about keeping data and operations together in the same place? Where are the operations on this data? They're not here, right? Because all we have is a structure with gets and sets. Right? And indeed, right, you should go through your assignment and ask yourself, how many classes do you have? Oh, there's a Q class, there's a node class, might be a utility class. And so some people have 3 classes and 1 class with just a structure and no operations on it. Another class, utility class, only had functions, no data. So 2/3 of your classes were not really classes. Right? They weren't keeping data and operations together. So what are the operations here? Anyone? There's no operations? Then why just get rid of the data? We don't need it. There's no operations, we never use the data, just throw it away. Right? If we never use the data, then what do we need data for?
Use it in a different class.
Yeah, what's the operation? What's our data here? Oh, come on, that's an easy question, right? There's 3 fields, right? Whole point is to hold the value, right? Hold the value and give it back. That's it, right? That's all we need to do with the value, right? So what do we do with the other 2 fields? Oh, come on.
Internal pointer, not for exposing it, just for internal mechanism.
Yeah, we have to set kick those lengths up, right?
Yeah, yes.
Right. So here, here's an example of where it was used, right? And so there's some private method add, node to queue, right? And I pass in a node, the current node, and then I create a new node, and then the new node, the next one has to set to the, I'm setting, right? To the start of the queue, and the previous has to go to the current node, and then the start of the queue previous has to go to the new node, right? And you've all done this, right? There's previous and next, and you have to do the current, the new node has to point to the right one, that one has to point back here, and that's back to the previous, right? And so there you go, right? I'm pulling all the pointers out, into them here, right, in my queue class. Right? And of course, everyone did it this way. Why? Because all our data structures booked this way, right? They create a structure, and then they do a pointer stuff over here. Now, it turns out there's a hidden assumption with this piece of code. Well, and what's the hidden assumption? Let's see, current node, and now, so the new node is going to point to the start of the queue. That's going to be the next one, right? And the previous is going to go to the current node, right? And that's right there is new node set previous to current node. And then current node set next to new node. Which means for this to work, current node better be the last node in the queue, right? If it's not, we just chopped off a bunch of stuff. So, there's a hidden assumption with this code because current node better be the thing that points to the start of the circular queue, right? And so by doing it, in this case, in the Q class, we set ourselves up for possible bug. So here at process node, right? Why not? Okay, here are the three fields, and then okay, we need a constructor, and then set the values, and then I can have an add method, right? And pass in a new node, and then there it is, right? And now the outside world doesn't have to do this. Right? We do it right here. Inside the class that has a pointer. And we can test to make sure it works, right? I can take two nodes and add one to the other node doesn't work, right? And then, right, now I actually prefer append. So I wrote this out the first time I put append, but then it's like Java, oh, I'm in Java, and Java, in all the question classes, they never use append. They always say add, and when they do the definition add means append, right? So okay, I then had to change all my appends to add. I still prefer append because I think it's more descriptive of what we're doing here. But, and now, right? Oh wait, and if I make it generic, right? Instead of having a class that only works in this assignment, only works for a process object, now I can use this, right, anywhere. So I can use this in a generic Q class, right? And for almost no extra work, I get something that goes from only being useful in one assignment to something that has the potential for being used in many places. And then we take this whole thing, right? And now it becomes, give me the start queue, give me the previous one, and append to it, I'm done. It's a small little thing, right? But it does several things. One is it reinforces the idea that data and operations go together. And secondly, like the whole goal of object programming is, or part of it is to hide things, right? So little things do their thing, and now I don't have to worry about those things, right? So in the Q class, I don't have to worry about next, previous, or how do I?
So, if, like in my instance, I had a size that was a counter of the size.
Right.
Would you recommend doing that in the Q class or in the node as an inner class and then reaching out and doing it?
The size?
Yeah, the size of the whole queue. Because the node could do it by, as an inner class, it could, go out to this pointer and do it because they have access to the, private members. Or would you do it outside and then call the node and keep the? There's one instance you've got the code all in one place, but it's kind of pointing in two directions. In the other instance, you have code in two places, but they're kind of a better fit for where they are.
So for the size is an attribute of the queue, right? It's not an attribute of a single node.
Yeah, I'm just saying in Java it could be accessed by either the inner class, node class, or the outer class.
Yeah, but again, for me the size is an attribute of the overall queue.
Okay, so you do it on the outside.
Yeah, just because the nodes, I mean, what's their responsibility, right? Node responsibility is pretty simple. It's like I hold a value and I have to give it back when someone asks for it, and then I have to keep track, of my position in the list, and then I'm done. That's it, right? That's all I have is value, previous, and next. So it's not really the size of the whole thing is not part of what I can do. Now, if you want to compute the size dynamically, we could add that to node class. You go to the first one, say, give me your size, and then it propagates through. But it's just easier to store that in the queue, and then every time you add something, you just increment. Every time you delete something, you decrement, right? I'm on a mission to get people to stop using systems.print, right? There are certain places where printing the standard out makes sense, right? If you're writing a Unix utility, then all the utilities work by piping the output to standard out, right? So you can then pipe it. You connect it by a pipe to input from something else. But how many of you have ever written a Unix utility? Yes, I thought there's one or two, right? Now, when we're dealing with Lambda, on AWS or serverless stuff, yeah, you write one function and have to write the standard out so it can make it extend someplace. But there are very few places where it makes sense, right? Other than that, system.out.print line is for debugging. That is its main use. Why? Because otherwise, when you write code that other code uses, you can't capture that. We don't get the information. When you're writing a little program that you can throw away, right? Yeah, okay. So here, it's just telling you, okay, I'm removing something. I'm adding something, right? She was actually when you run your little program before I turn it in, you see the output, but it doesn't do any good, right?
In the Microsoft world, and I don't know what it would be in Java, but there is a way in the Microsoft world to trace things to the debugger without spitting them out to the user.
Yeah, so that happens a lot, right? I mean, you write something in the back end, if something goes wrong, you need how do you know if something went wrong? You don't want to find out when you've got 1,000 calls from a customer saying it broke, right? And even then, they just say it's not working. They don't tell you anything about how that's useful. So yeah, you want to log things, right? And that goes to files that you can look at. If you're on mobile, you want to be able to have analytics to tell you what's going on, what people are doing, etc. So Java does have a logging system you can use to write the logs. And then, there's a standard thing where you can specify how big the log file should be, and then it creates multiple ones and rolls them over and all that stuff. And then you can log whether it's a severe or warning or different levels, and you can turn them off or on, right? So when you're developing, you can have a higher level. There's something wrong with this class, I can turn on trying level debug statements or logging statements for that class and turn them back off when we go into production. And system, like I said, it's useful for debugging, right? That's part of what we're talking about.
Yeah.
But also, when you go in production, there are times when you need to capture the information.
Yeah, the application I'm working on, we have millions and millions of, it logs to a database.
Yeah.
And millions and millions of lines, but then when something goes wrong, you got to do a bunch of queries and figure out what time and where and how and all that.
I've written little applications I use, and I log what I do, right? So that, did I actually send an email? Did I actually do this or that, right? But that's not about that print line.
That's maybe the spirit of it. I don't know.
Yeah, it's the same spirit, but it's
not well implemented.
Yeah, it's for debugging, right?
When we sort a queue and then on the display it, do we print the results or do we return the queue?
So the question is, when you have a queue, how do you display it, right? The first thing you have to ask is, whose responsibility for displaying it, right? Is the queue responsible for displaying itself? Well, how do you display it, right? even in this example, right, on my machine here, I've got two ways of displaying the data. One is I go into Unix, command line, and I type top. And then I get a textual representation that's refreshed over and over again. It's textual, right? There's also an application they wrote called Activity Monitor, which is the same thing, but now it's a graphical interface. Completely two separate ways of displaying exactly the same information from exactly the same source. Right? And presumably you've all heard about the model view controller, right? Set up where when you've got a GUI application, you separate the view part from the model, right? Well, the view is just the display, the output, right? And we typically think about that in terms of GUI elements. What you're really saying is, yeah, the output varies frequently, right? And I know you want the button green, you want to move down 3 pixels, right, all these pretty things. But the same thing happens, you know, displaying texture results too could change. So we want to keep them separate. We don't want our model classes, AQ, to worry about how I'm going to display things. Right? And so what's happening in two situations, right? When I type top, right, this colon code, which continually, you know, goes to the job queue, the process queue, and grabs all the data, and then transfers all strings the right way and formats in this fractal thing. Because you have to, how do you format these strings on a terminal, right? There's all these old-fashioned control characters and right things you do. But also in the GUI program, you query the same underlying code, the same information. So the first thing is, those two are separate responsibilities handled by separate pieces. And then the question is, how do I get the Q class to provide the information the other piece needs? Well, the standard way in Java is two ways, right? One is to provide an iterator in a collection, so you can go through them all. And the other one is to array. When you hand off, here's an array of all the elements I can take. Right? So now my Q class has handled its part of responsibility. Its part is not to physically print on the screen or send it to a GUI element or send it to a file, because we never know which one we want, right? And it can change our mind. So make the Q class independent of the view, which is the whole thing about this, the view model controller is the view should be separate from the model, right? And right, so there's printing things out from the Q class. You're adding responsibilities to Q class that doesn't belong there, plus, right, you're coupling the Q class with a particular output device, a particular way of doing it.
And what about the warnings? Not for Java, but for mobile, what we have warnings
Warnings of,
for UI or anything.
yeah, so the question is, in the view you might have warnings, right? Alerts, I mean, this doesn't work, right? No such file, right? So your model has to provide the functionality to tell the view, hey, there's something wrong here, right? You're trying to save to a file, the file doesn't exist.
So those are not system, not output, not exceptions.
No, because when you're in a GUI program, right, it doesn't go to GUI, right? It goes to standard out. When you've got an application, where's standard out? When you have a web view, now you've got the back end, which is a different machine. The standard out is going to a log file. So hopefully you're logging it. And then on the client side, yeah, when you print in JavaScript, it goes to the console. But how many people here have ever written the JavaScript console? Yeah, like nobody, right? A few people. So no one ever looked at it.
And still for displaying, once we are at the level of the process, in this case, should we just print the itself? In this case, because there is like,
Well, so in this case, right, there's two things. One is not the Q class,
yes.
right? And so the Q class, it has the responsibility of saying, here's my iterator, or here is, right? And then someone else displays it somehow.
So here is the process.
No, the process, what's the process supposed to do? It doesn't know where you want to print things out, right? So no. You know, the two examples I have, one goes to a GUI application. And the other one it goes to sort of standard out in a terminal. But it's a weird standard out because you have to format it properly.
So our function to sort the queue should only return the queue and not display it in any way.
Yeah, if it's sorting is sorting, right?
So it's just returning the sorted queue. It does not display the queue.
Right.
Okay.
So there's a separate responsibilities, right? Sorting, why try sorting with printing? So, yeah, I mean, for debugging, it's fine. If you're writing Unix utility, it's fine, but don't write Unix utilities using Java. The startup time is too long, right? How long did it take to start up a job with a VM?
Does it take a long time?
It could take several seconds. Which, you know, if you're piping, you're creating a little shell script to pipe things that have two of them written in Java, and you take a couple seconds each, right? Perl is faster than Java in that case, right? Or Python. Yeah, so this just don't. It's good for debugging, but that's about it. Oh yeah, and then the other thing is you're nesting these else's, but you're returning here, right? So if you ever go in here, you never go anywhere else, right? You're done, right? So you can just do it, right? If it's empty, return null, done. You don't need the next thing, right? So we can. And then if size equals 1, I'm done. Forget about that case, right? So now I've got rid of the two wacko cases. Now I can do the normal case. I don't have to worry about it, and I'm not nested inside like this. People call these guards. Some languages have constructs to do that. Just do a guard. Just tell them, look, I'm taking care of these edge cases, and now we can do the retro case. I don't have to worry about anything else, and I'm not nested inside this.
Is there a limitation to the number of values we return in a function? Like, that should be minimum, is it?
Well, some people say there should be one return statement, but you know, if they do it, I've got a couple returns right away, and then the main case. The problem is if you only do one return and it's laid in the bottom, and then you got special cases up here, and then you have to keep that in your head to go all the way down to make sure I return the right thing at the end. It's like, that's just too much. That's going to cause problems, because that when the code is here, and then I finish it down there, and then the code finishes down there, it's like, oh, that's a bad idea, right? Like, no, I'm done. I've done that case. Forget about it, right? I don't have to worry about it way down here. I've done this case. Forget about it. Now I can do whatever. Right. I like. Forget about that case. Don't have to worry about You have nested if statements like, oh, did I get that right? All the else's and else's, all right. And it's done, right? And again, print is like, who are you talking to? And then it's like, check and create notes. Like, what are you checking? Yeah, you know when you wrote the code, right? And you all know it because you did the same thing, but when you come to this and read it, check and create notes. Like, what are you checking? Are we checking to make sure the process is right? Or you know, ensure capacity, right? How I come up with that? Well, that's what Java does. I mean, you look at, go to the source code, right? And inside a array list, it's like there's going to be a method called ensure capacity. What's it do? It ensures that you've got the capacity to do the job, right? That involves checking to see how much capacity is. Are you full or not? And if you're full, then you make it big. And then, of course, use standard name instead of, you know, standard Java name, which is not necessarily the standard Python name, not necessarily the standard C++ name, right? And then, in Java collections, add always returns a Boolean value. Why? Because the add may fail. So again, if you're in Java, then your add method should return a Boolean because that's what experienced Java program expects it to do.
Yeah, it's interesting because the add for Java actually returns true all the time, or it throws an exception, which I thought was kind of interesting.
Yeah, I know, it's weird, but that's
kind of a weird mixed model, you know.
Yeah, and that happens, right? I mean, they couldn't make up their minds, right? And the problem with that is now, if you take it seriously, some people will then check the value, right? But if it's always true or exception, then they just wasted their time.
Backward compatibility, maybe.
Could
At one point it was true or false, and then they actually changed
change
it.
your mind, yeah. Then, right, why not make it a generic? Because once we make it generic, we have a Q class that we can use. And then, if we make that Q class implement Java with an interface, now it fits in, right? Now, not only can I use it with anything, I can also swap it in or out with the Java Q class. And then, well, they even have an abstract Q class which implements most of the methods. And you want to put a few.
Were we allowed to use that though? Because that actually has code in it.
That's another story, but how many people here even thought about that interface? That's what I thought, yeah. Years ago, I had a student, and he was in a class, and had this project, and had this team, right? And he said, it was really hard because everyone's like, okay, I'm going to do this design task, and they all want to work. And he's like, no, stop. Java is this big, huge language. It has all this stuff. There might be stuff there that you can use, right? You have to just use it. And he had a hard time getting students to tell students, like, just look for stuff in there, because you might find something useful, right? And it'll save you time, right? And when you're working in a language, there are standards, there's libraries, and looking at Java, the standard library is huge, right? And they come up with a lot of ways of doing things, and that's what it becomes easier if you follow their way, right? Now this Boolean value, right? It may be a silly convention, but it's a convention, like it's a standard, and a silly standard is better than a good non-standard way of doing it, right? You really need a good, really good reason to say that really sucks, and we're going to do it this way, because everyone's going to use it this way, right? And so even though your way may be much better, it's going to, it will confuse people later on. It's like, well, wait, I mean, everyone else does it this way, why did you do it that way? No, don't do this, right? So like, we're combining two classes into one, right? The process now becomes also the node, and that means you can only put, and when it's slightly confusing, because like, why does the process has to know about previous and next? And you only, that basically means you can create a linked list of process objects, not anything else. And this is also confusing, making the Q class also the node class. There's no operation which is related to the queue, and some other nodes. This one. Only a few people did this. I took lots of points off for it. I should have gotten more, but I didn't. What's the problem with this? Well, okay, so I create two Q objects, right? And so I add something to A, and the size is 1, that's all good. And then I add one to B, and the size of B is 2. Why is that? Because, front and rear are static, right? So there's only one, as you've got all instances of the Q class, and so when you add things to B, B has the same contents as A. And of course I tested it, right? But they only created one Q and all worked, right? And of course A is size 2, right? Don't make your field static unless you got a very specific use. This is Python. What's the naming convention in Python for methods? Yeah. Well, underscore readability, right? So that could pass, so that's hard to read. So you really want that, right? And then of course, no, in Python, when you go to the functions, you look what they do, they don't use add, they use append. So in Python, you want to use append, where in Java, you want to use add. That's it. Your code reuse, making good code is hard, right? It's very hard. And if you sit down and you focus on, I have this assignment to do, right? It's not going to happen. It also requires experience, practice. But you have to ask yourself, step back and what am I doing here? What's the responsibility to that?
I had given
a doubt regarding having the add function in the node class. So I understood the underlying reason
Right.
of the hidden assumption of the
Right.
current pointer in queue. But is add really a responsibility of the node class?
Well, the question is, when we talk about keeping data operations together, right? What's the data the node class have? It has the value of holding, and the only thing we want to do with that is store and return it. The other thing you have is those two pointers, right?
So node is not a data class. It is
Well, see, my problem is that we're talking about keeping data operations together, but then it's like, oh, except when we have a node class, oh, except when we've got a utility class, except when it's building strings, except when it builds this, and I'll pretty soon, like I said, half or 2/3 or 3/4 of the classes you wrote for this assignment are not really classes. And if you're taking a course in object-oriented design, where I spent the last 2 weeks talking about keeping data operations together, and half or 2/3, 3/4 of classes don't do that, what happens when you get out in the real world? It's not easier, right? It's not going to get easier. Right? So my goal here is to try and make you think, oh, what are the operations and what are the data here? What are the operations and the data? Are they being kept together or not? No.
Is it better to add the operations to the node class or just change to a structure?
Well, so what do you gain by changing to a structure? Same story, right? Maybe more honest, but you're still just same. I think the very first lecture, second lecture, I said, what's the difference between having a struct and having a class with getting sets? Structurally, it's the same, right?
So in such case, do we add node as the inner class to the queue class?
Okay, well, it depends on what language you are, right? Some languages don't have inner classes. Do you need it as inner class? Does the node need to access any data from the queue class? So does it need to be inner class to gain anything? So like I said last week, this assignment's worth 1% of your grade, so don't panic. I will post the grades online, probably not today, they're going to go to class, and then by the time it's 8:30, I'm tired and want to go home and work with other things besides posting grades. The entire goal of this assignment was to just try and get you to pay more attention to what you're doing, right, when you write code. That was his goal, right? And I set various traps, right? The description about printing and displaying. I didn't ask you to print or display. I said the code that uses you, right, has to be able to print or display, right? It was a trap. See what happened, right? Because I know students are so used to doing just another print line when it's not really appropriate most of the time.
So did you expect it, because that was kind of unclear with the assignment, did you expect us to write a sort or not? Because you said people who use your code will sort. So initially, I wasn't going to write a sort, but then I thought I saw on the wiki where someone said the sort was needed. But I was just curious what your intention was there.
My basic intention, usually when I give assignments, is to set up design issues and then see how students solve them, and then do this.
I guess, in other words, would you have marked off points for someone who didn't include a sort at all?
No. And there are a few people who didn't, right? Now, they may have done it just because they're out of time. And that's often what happens. The second assignment is that people come to me and say, "Is this right?" Right? And the problem I was saying, "Is this right or wrong?" Right? Is that what's important here is not what you did, but how you make the decision. Right? Is it the Q class print out or not? Yes or no? Why? Oh, because that's a responsibility that doesn't belong in the Q class. Okay. But you say, "Oh, don't do it," means, well, you just don't do it, then you don't think about it, right? Which is why, like someone what you said, "Why are they using comparator?" And I go, "Oh, because that's what you want to do." But if I said that, then no one thinks about, "Oh, what should I do?" Right? They just say, "Okay, the instructor said do this, so I'm going to do that." And then when I do this, everyone's going to say, "Oh, I'm so glad I did it the right way." But you didn't do it for the right reason. You just did it because someone told you to do it, right? Which is not the same thing as stepping back and saying, "Oh, what should happen here?" Oh, right? I'll see you people on Thursday, but then I should have a second assignment out.